of Business Intelligence. Today is the 13th of November. We will look today at regression algorithms, 3 of them, linear, polynomial, and logistic regression. With these algorithms, we make predictions based on data, okay? So the hypothesis is that we have data from the system. The system is a management system, okay, usually some KPIs. And the goal is to predict the behavior of the system based on the data, okay? So we want to predict, make some predictions, and for that we first are going to explain the linear regression. Okay? As you know, any line has an equation y equals b0 plus b1x, okay? And b1 is the tangent of the alpha degree of the line to the horizontal, and b0 is the cross with value x equals 0. Okay, so in general, if we have two axes here, okay, and we have some data, we want to predict what is the equation of this line. Okay, the equation of this line is going to be something like that. This point is going to be 0, and this has a how do you say, eine Steigung, a pendiente, okay, of degree alpha, and that is going to be b1. Okay, so let's make an example. Let's do an example, and it's then easy as a piece of cake. Step 1, we gather the data, okay. So we have x and y, and then imagine these are just 2 KPIs. Okay, this is calendar week 1, calendar week 2, calendar week 3, and calendar week 4. And then we have 3, 6.5, 4, 8.5, 6, 13, and 3, 3.5. Okay, this is just the coordinates of the points below in the graphic. So the step 2 is to calculate the mean value of the variables and of the variables. And it is important to remark that the linear regression crosses the mean value So the linear regression is going to fill the equation y mean value equals b0 plus b1 x mean value. Okay, this is important. We're going to use this to generate our linear regression. So to calculate the mean value of x, it's easy. Okay, we have 4 data sets, so this is just adding 3, 4, 6, and 3. This equals then 4. And the mean value of y again equals 4. 6.5 plus 5.5 plus 13 plus 3.5 equals 7.87. Okay? So this is just a piece of cake. I don't need to explain how to calculate a mean value, right? Step 3, we calculate the slope of the line. So we calculate B1. The slope of the line has this equation. B1 equals the sum for all I of x sub e minus x mean value times y sub e minus mean value divided by x sub e minus x square added up to all the values. So I could just go on and give you just the equation and say, hey, take it and learn it and fuck you. But I will not do it. I will explain what it means, okay? Because it is important that you learn how to understand mathematics with images, okay? It is very important that you understand what it means geometrically. So what does this mean geometrically? Why is this the slope? Imagine we have this data. We have here our mean value of the data, okay? This here is x mean and y mean. We have just calculated them. And then we have one data point. Okay, this data point has x sub e and y sub e. Okay? Now please pay attention to the thing, to the blackboard, because the meaning of this is the area of this square. Why? No, look here. Why? Because this is xy minus x mean value. And this is epsilon y minus epsilon mean value. So, Länge mal Höhe, Masse por Altura, die Fläche von dem Ding. Okay, so this area is this. All right? And we want to calculate, we say this is the scope, this is the slope, okay? The Steigung. So we need to, this is a square, this is an area, so we need to divide it by something also squared, and we need to compare it with the horizontal. And the other concept is that this square the area of this square, let's say this one, okay, is exactly that, okay, the area of that square. So if we compare both areas, and if it says 1, it means that they are the same, right? So we have 45 degrees. The tangent of 45 degrees is 1. If the area is bigger than 1, it means that the upper term, let's say this one, is bigger. So the slope is bigger, it's higher than 1, than 45. If it's lower than 1, then it's going to be less than 45 degrees, okay? So never go through an equation without understanding it geometrically. Geh niemals durch irgendeine Gleichung in Mathe, ohne sie geometrisch zu verstehen. Macht euch Bilder. Okay? Weil dann ist Mathe einfach. Und anyone can understand it. The problem is not you, the problem is the guy explaining it. Okay? So a lot of people have problems with math because it's not properly being explained, I think. Okay? So you get the meaning of it? So when we do this equation now for our data, we have 3 minus 4 times 6.5 minus 7.87 plus 4 minus 4 times 8.5 minus 7.87 plus 6 minus 4 times 13 minus 7.87 plus 3 minus 4 times 3.5 minus 7.87 divided by 3 minus 4 square plus 4 minus 4 square plus 6 minus 4 square plus 3 minus 4 square. This equals 4.83. Okay, so our equation so far is B0 plus 4.83x. Okay, so now we need to know B0, but B0 is easy. Step 4, let's calculate B0, because the line goes through y mean value plus B0, 4.83 x mean value. You have questions? No? No, the other guy. You have questions? No? So this means that if we put the values that we have from above, this is 7.87 plus B0, equal B0 times plus 4.83 times 4. Okay, so B0 equals minus 11.46. So the final equation is y equals minus 11.46 plus 4.83x. okay? Now I can say, how do we make the prediction? If I don't know, x equals 3.9, what is the predicted value of y? Well, we just plug it in. The predicted value of y equals minus 11.46 plus 4.83 times 3.9. And this equals 7.39. Okay? So, any questions? No? Piece of cake. This is called linear regression, okay? If you do it in Python, it will take less than 1 second. So, the second thing we are going to look at is the polynomic. Regression. This is when the data are not linear, okay? So we aim to have a relationship that is not linear. For instance, let's say we are going to do here a quadratic regression. For more than quadratic, so if you want to do cubic or something like that, you need Python, okay? Because it's just too much. So the quadratic regression is going to be something like ax squared plus bx plus c. The data is gathered here. So we have here data x and y. Let's say easy data, okay? And I especially recommend that you do these exercises again with different numbers, okay? So just give yourself different numbers and try yourself in the math. Especially in the exam, if I ask this is not very difficult, but you need speed. Okay, so in the exam there's no time for inspiration. In the exam it's time for killing. Okay, so you need to go to the exam to kill it, not to get inspired somehow. So you need to know, do it, and go. Okay, it's like war. Go there and kill it. So what do we do for the quadratic regression? So we take, we have 3 parameters, A, B, and C, that we want to find out, okay? So we take 3 points, let's say 2.5 equals A times 1 squared plus B times 1 plus C. And then 5.8 equals A times 2 squared plus B times 2 plus C. And then 11.9 is A times 2 times 2 hoch 3 plus B times 3 plus, 2 times 2, 3 times 2, plus C, okay? So with these 3 equations, we can solve the problem. We can solve the 3 parameters. So this is equation 1, 2, and 3 is 3 equations, 3 parameters If we do 2 minus 1, we have 5.8 minus 2.5 equals 4a minus a plus 2b minus b plus c minus d. So that we get 3.3 equals 3a plus b. Okay? And if we do, let's say, 3 minus 2, we have 11.9 minus 5.8 equal 9a minus 4a plus 3b minus 2b plus c minus c. Going forwards, this is 6.1, 5a plus b. Okay? So this is equation number 4, this is equation number 5. There is a number of ways of solving this. I am not going to, make a lot of fuss about it. If we do 5 minus 4, this is 6.1 minus 3.3 equals 5a minus 3a plus b minus b. So as a result, you get a equals 1.4. If we plug this in, let's say on equation number 4, then b equals minus 0.9, and if we plug this in equation number 1, then you get c equals 2. Okay, so the final equation is y predicted. Maybe we should write it. I should write it like this. Make sure you put here a little hat, okay? So y predicted, this is what this hat means, okay? Is 1.4 x squared minus 0.9 x plus 2. Okay? Again, solving a linear equation, 3 linear equations with 3 parameters is like 7th degree or something in the school. Okay? So, what is the value? Of y predicted if x equals 0, okay? Y predicted for x equals 0 is 2. All right. So this is polynomic and linear regression. This is the easy part of the lecture. Okay, now I start with the logistic, which is a little bit more challenging. Okay? So logistic regression. Is a type of regression used when the dependent variable y is binary. Highlight this, okay? This is important. True or false, black and white, yes or no, whatever. Okay, so we have to decide. It's like a decision. This is used in deep learning when we decide between two characters, okay? I make a picture and then I say, okay, this is Mercedes or this is BMW. Just Tell me which one. Okay? This is the last layer. This is the concept, logistic function, logit function is the concept used in deep learning to decide between two categories. Okay? So it predicts the probability of the outcome based on one or more variables. These are called X sub E. Okay? So here we use a threshold for instance. Usually it's 0.5, okay, to decide if is the output is 0 or 1. So if the probability of the output is 0.4, then we decide to 0. If it's bigger than 0.5, we decide to 1. Okay? So, hallo, herzlich willkommen. Example. A professor wants to predict whether a student will pass y equals 1 or fail y equals 0, an exam based on the number of hours they study. This is my variable x, okay? We can have more than one variable, but we use, in this example, we use only one variable. So the data is like this. X are the hours, and y is pass for a 1 or no pass for a 0, okay? So, and these are the data. 1 hour studied, no pass. 2 hour studies, no pass. 3 hour studies, no pass. 4 hour pass. 5 hour pass. 6 hour pass. Okay? So this is the step 1, gather the data. We have the data. Step 1. gather data, okay? So just like in the other one. Step 2. This is the new part, okay? Step 2. Use the so-called logit function to model the relationship. Okay? So the logit function is the logarithmus of p divided 1 minus p equal b0 plus b1x. Okay? So what does p mean and so on? P is the probability of pass. Okay? So the probability of I with a hat equal 1. B0 is the intercept. For x equals 0. And B1 is the slope of the function x. So how does this looks like in a graphical way? This is x. This is y. Okay, this is p. So 0.5 is going to be there. And then the equation looks like this. Remember, 0.5 is our threshold, okay? And this tends to 0. This tends to 1. Okay? So whatever data points that, look at the blackboard, please. Hey. Hallo? Gucken. Gucken. Verstehst du mich? No? You don't understand? Okay. Look at the blackboard. If the points are here, then it's going to be 1. If the points are here, it's going to be 0. Okay? The problem we have is if the problems are here, if the points are here. We don't know what happens there. That's the weak point of this logistic behavior, okay? So to solve this, we have a little bit of math, okay? So p divided by 1 minus p equals the exponential of b0 plus b1x. This means that p equals exponential of b0 plus b1x minus p times e b0 plus b1x. Okay? So this means that p multiplies 1 plus e b0 plus b1x equal e b0 plus b1x. As a result, p is going to be 1 divided by 1 plus e to the product of B0 plus B1x. Okay, this is just playing a little bit with the equation. To get to the solution, how to measure P, okay? This equation is this equation, okay? It's this Rosa line. So this is the general solution. Now the step 3 is to solve it. So now we look at the data. Where is the change between 0 and 1 very likely to happen? Between 3 and 4, right? So somewhere here, between 3 and 4 is the change. So here we go and say, we can solve this analytically, okay, but this is way more complicated. So we say x equals 3. Then y is 0. X equals 4. Then y equals 1. Okay? So we assume that if x equals 4, then p is 0.5. We assume that here we are between 3 and 4, okay? And then we assume that. And with that assumption, we say, okay, we apply this to the equation above. Logarithms of 0.5 divided by 1 minus 0.5 equal B0 plus B1 times 4. And we assume that for x equals 6, P is going to be 1. So logarithms of 1 divided by, P is going to be 0.9. Cannot be 9. Cannot be 1. So very high, 0.9. 1 minus 0.9 equals B0 plus B1 times 6. If I ask this in the exam, you can make another assumption, okay? It can be different. You don't look very convinced. No, it's not fine. No, it's not fine. You ask.
So it's like, how do I say it? So I can make the assumption based on the point on the table I assume that it's going to switch.
Yeah.
So if I say it's maybe like 3.5, it will be fine.
No, you don't have data for 3.5.
Okay.
Yeah. You don't have data for 3.5. You can take 3. Okay?
Yeah.
But you cannot take 3.5. It doesn't work because you don't have data for 3.5. Okay? Yes?
If you take x3, p must be under 0.5.
Yeah, it could be 0.4. Okay? So you can make different assumptions. So here we have the logarithms of 1, which equals 0, is b0 plus b1 times 4. And the logarithms of 0.9 divided by 0.1 equals b0 plus b1 times 6. Okay, using these two equations, we have the logarithms of 0.9 divided by 0.1 equals 2 times b1. So b1 is going to be 1.1. And if we put that in the equation above, 0 equals P0 plus 1.1 times 4, B0 is minus 4.4. Okay? So our logistic regression is going to look like this. It's going to be like this. So going to have this equation, P equal 1 divided by 1 plus E minus 4.4, sorry, minus 4.4 plus 1.1x. And this has somewhere here in 3.8 and in 0.44 the value that is interesting, where things change, okay? Left from there is not very interesting. Okay? And this is logistic regression. These are this is the fundamental decision criteria for deep learning in 2 categories. Okay? So if we say, what is the probability of pass after 3.8 hours study? Answer is 44%. Okay? So if you study 3.8 hours, the probability of passing is 44%. If you study 5 hours, the probability is 0.7 or whatever. Okay? Does it make sense?